Young people, welcome back. BMB in the house, y'all. Ready to knock another one out for you. Let's see what we got. Chapter 9, Lesson 1, Graphing Quadratic Functions. Looks like, number 1, analyze the characteristics of graphs of quadratic functions. And number 2, graph quadratic functions. There you go. Swap back. Students will be able to graph quadratic functions and kind of analyze them, know about them, just know what you're doing. So the concept, quadratics, the skill, graph. So we'll be graphing quadratics. Let's get this one started, y'all. All right, there it is, and there it goes. So, getting started, guys. The beginning of a new chapter, gotta love it. We've been messing with quadratics, polynomials for a while, but we're graphing. Graphing means we're gonna put it on a coordinate plane. And number 1, 2, and 3, what technique are we gonna use? Wow, look at that beautiful graphic organizer that just slid right on in. Didn't like that one, so we slid in another one. So guys, find what works for you. Do what your teacher does. We're going to use the plug-in method. Use table of values to graph each function, state the domain and range. Understand that the domain is your x values and the range is your y values. So just stating your domain and your range. That's that understanding. But in a situation like this, plug and go, plug and go, plug in and go. So we're going to plug in 0 for x, 0 times 0 is 0, of course. And then, of course, we still have a -4, so y will equal -4. We actually now have an intercept, right? So 0, -4 is my first point. Taking a look at the next one here. And as I do, we can plug in any value, 1, 2, 3, any value on the x-axis, right? So you can plug in 1,000, but why would you do that? So we use 2, 2 times 2, 4, 4 minus 4. Get it, get it, get it. Of course, it's 0. So we got 2 values. Let's get a third. You notice I did 2. Well, I did 0. I did a positive. Now I'm doing a negative. So plug and go. Y is equal to, parentheses, squared minus 4. We're going to plug in -2. -2 times -2 is going to give you 4. So y is equal to 4 minus 4. So here we go again. 4 minus 4 is going to give me, good. So, got our third point. And again, guys, it doesn't tell you to make 5 points and graph it. It tells you to graph it. So you can make as many points as you need, right? So recognizing what I'm doing, I got to plug in one more value. So I got a 0, I got a positive, I got a negative. Let's go for another positive. Y is going to be equal to, parentheses again, squared minus 4. Inside my parentheses is 3. Now some of you guys might have used 5, might have used -1. Again, you can pick any value. Your table of points is your table of points. So, and if you're just following me, that's excellent. After we plug in, we get 9 minus 4. 9 minus 4 is going to give me 5, so therefore, 3, 5 is my last coordinate. Here comes the fun part. Plotting points. So again, x is horizontal, y is vertical, and there's my first. Boop. There's my second. Boop. And here comes my third. Boop. And it looks like a quadratic. It's gonna make a U, guys. So what we do is we curve it. Let's see how this curve. Oh, I'm sorry, I have one more point. 3, 5. And axis of symmetry. That's where the next point's coming in. And here it goes, smooth, like a U. So it's not a sharp V, that's a different function. We're doing quadratics, so it actually curves, right? And hopefully the teacher is spending a little bit more time, explaining that and going over it. But for our purposes, let's get through this concept and this skill, right? So the second one, there's my table. Again, I'm going to do nothing different. I'm going to plug and go. Y is equal to negative parentheses, squared plus 3. Plugging inside of that parentheses, I can pick any values on the number line. always use 0, always use positive, always use negative. So there's 0, positive 2, negative 2, and then I can, we'll go again. So 0 times 0. Now negative 0 is still just 0. So y is just going to equal 3, first value. 0, 3, first coordinate. You hear that? First value is 3, but the first coordinate was 0, 3. So now for second coordinate, y is equal to negative 1, because it's the invisible 1, parentheses, plug in a 2, squared plus 3. So now 2 squared is 4, so I'm going to have negative 1 times 4. And then I got to add 3. Multiply before we add, so y is equal to negative 4 plus 3. And of course, leaves me with negative 1. All right, plot that. I'm sorry, put it on my table. We'll be plotting it in just a second. Now let's go ahead and get this negative in. So the reason why, guys, you always, when graphing quadratics, or just graphing period, you want to pick positives, numbers to the right of the origin. You want to pick negatives, numbers to the left of the origin, and you always pick 0. So we're going to pick 0, a positive, and a negative. So if I use positive 5, I can use negative 5. If I use positive 1, use negative 1. But just understanding that I want to see how this graph looks. I'm not going to have every single point, but I'll have enough to graph it, right? So with that, plugged in negative 3. And here we go. Y is going to be equal to negative 1 again, parentheses. That thing is right there on me, huh? Square plus 3. Go ahead and plug in, and I like how I'm using my blue. So here we go. And break it down. Negative 1 times 9, negative 3 squared, plus 3. So y is equal to negative 9 plus 3. And then, of course, I got more negatives than positives, so y is equal to negative 6. And I've got enough points. I got enough coordinate points now to place this on my coordinate plane and feel good about the u that I'm going to now create. So first thing you also notice is the coordinate plane there in number 1, it looks right. Your origin is right there in the middle. But for this one, your origin is a little higher, right? That's because this has a negative leading coefficient, which means your parabola is going to be upside down u. So there's 0, 3, 2, negative 1, negative 2, negative 1. I'm sorry. Yeah, 2, negative 1, negative 2, negative 1, negative 3, negative 6. And then the axis of symmetry. Again, I'm going to get that last point over there, because if I plug in 3, again, negative 1 times 3 squared, you're going to get the same thing. 3 times 3 is 9. You get negative 9. Negative 9 plus 3 is negative 6. So axis of symmetry. Looking good, guys. We're plugging in going, right? Plugging in going. So we got one more on this section. We're going to need some room, so what should we get rid of? Should we get rid of that? Or that? How about that? We need more room. And that. And is that enough room? Yeah, it's enough room. So there's my table that I'm going to fill in with values. And again, I can decide. At this point, I pick on Sergio. I pick on Billy. I pick on Ritzy. You'd be like, give me some values. Huh? What values do you want me to plug in for X? I don't know. Well, then I pick on the next kid, right? And they say 0, and I go, you're so smart. So we're gonna plug in 0, a positive, and a negative. Slowing it down, 0 times 0 is 0, negative 2 times 0 is 0, and we still have minus 6, so 0 minus 0 minus 6 leaves you with negative 6, so 0, negative 6. Bam, got it. Next one. So I need some more room, more sweetly. I need some space. And I guess we're not going to make any space. We're going to just clean some things up here. Thank you. Thank you. So by just emptying it out, I can plug in the new value. All right. So now, instead of it being 0, I plug in, I'm going to plug in a 2. 2 and 2. So again, I got to erase, because now y is going to equal 2 times 2 is 4. Minus 2 times 2 is 4, minus 6. So 4 minus 4 minus 6. You get that? You see that? Not making it hard, right? 0 minus 6 leaves you with negative 6. So 2, negative 6. You like that? We'll see, right? Let's pick another value. We picked a positive. Let's pick a negative. And that doesn't look like a negative. So we're going to write that again. -2, -2. And let's clear out those parentheses because we're doing the same thing. Plug and go, plug and go. So clear it all. Clean it all up. Clean it all up. So I tell my 14-year-old son, clean it all up. Here we go. Plug in -2 and -2. So y is equal to 4 minus, no, not minus, plus. A negative times a negative is a positive. So 4 plus 4, and then minus 6, right? And here we go. 4 plus 4 is 8. 8 minus 6. Boom. Y is going to equal 2. And we're not done because we can fill in more values to the table. Sometimes they'll give you the table and they'll give you the X value and you can plug in. We're choosing the value. So we're choosing to do 4 points. We could do 2 points, but that wouldn't be enough for a quadratic. So I'm going to go ahead and use a positive 4 here. Cleaning things up one more time. And looking again, guys, just at number 3 in the coordinate plane, you see how the origin is so high up? That's for a reason, right? And again, I can literally count 1, 2, 3, 4, 5. So for my X value, sure, why not a positive 4? I get 16, 4 times 4. -8, -2 times 4, and then minus 6. So 16 minus 8, minus 6. 8 minus 6, y equals 2. All right. I'm feeling good. I filled in my value of points at my coordinates. And first point, 0, -6. Bam. Now this is where I'm thinking to myself, 2, -6, and then -6. I'm sorry, 2, -6 is my next point. Then -2, 6. I know about the axis of symmetry. In these parabolas, you can draw a line right down the middle of it, and it should always work out. So that's what we're noticing here, guys. You see what's happening? That is what you call what? So watch what happens here. For number 3, you see how 1 and 2 gave me a U, then the second one gave me an upside down U. Well, this one don't look like a U. It looks like a funky U, huh? I don't like it. And the reason why I don't like it is I'm missing my axis of symmetry. So y is equal to, I'm going to use another point. I'm going to plug in. What did I do wrong? I didn't do anything wrong. I just needed more points. If I plug in 1, see I made a little yellow spot right there for us. If I plug in 1, 1 squared is 1. -2 times 1 is -2. And of course minus 6. So now I'm going to get y is equal to a -1 minus 6. -1 minus 6 is -7. So now when x is 1, or that little yellow star is, y is, come on down. Come on, you ain't gotta come down much. Right there between those 2 reds. Now it looks like a U. Now I can connect the dots. La, la, la. Pee Wee Herman, Playhouse, if you don't know, I can't help you. But go ahead and connect those dots. And again, guys, I'm trying my best to make it curve. Because again, if this was a absolute value function, we'd have a U. This is a quadratic function. I'm sorry, we would have a V, straight V. This one is a U. I'm making U's and B's, you don't get it. All right, guys, feeling good. The first 3 was a breakdown of plugging in to get values to graph our quadratics. But again, going back to domain and range, X values are my domain. So for number 1, we have a table of points. And for number 2, we have a table of points. And for number 3, we have a table of points. So you would literally just list the X values and state those as your domain. And of course, do the same thing for the Y values. And domain for number 1, all real numbers. Now, if you were to list all the values, 0, 2, -2, 4, you're missing some of the X values because it goes on forever. That's why you put arrows on the end, right? But for the range, how do I say this? If you see the U, we're gonna do a pause. Pause. We have a U. It's right there. Now the U has a basement. It can only go, and it stops right here, right? So you have no y values below it. So that's why we see that it says y has to be greater than or equal to -4. So here's -4, you know, and so the u's on top of it. So I have all the y's going up, all the y's going up. So all of these y's up here, from -4 all the way to 1,260, whatever, right? But you will not have any y values below. So that's why we say the range is greater than or equal to -4. For the x though, you see it's on both sides of the x, you get all the positives and all the negatives for x. So that's why. Now for number 2, the u's going down. My leading coefficient is negative. So now again, it's not gonna go any higher than this, right? So the u's underneath. So we gotta say what? Let's play. What we're saying is for number 2, the domain again is all real numbers, but the range has to be less than 3. So everything below 3 can be my values for the range. All right? So a very simple concept once you understand what you're doing, but if you don't know what domain is, x values, if you don't know what range is, y values, and of course, it's just a lack of understanding the concept. It's not a skill thing. You can easily see and go, oh, it's not going to go any higher than that, right? So for the last one, again, since it's a positive quadratic, it's going to be a u, regular old u. So the domain is all real numbers, but the range, all values greater than what? Where does the u, right about there? Greater than or equal to 6, right? -6, I'm sorry. Hey, there it is. That's what I was using my hand. Now I got the, see how it works out? That's how it works out. That's why you come, that's why you watch. It makes sense. If you don't, leave a comment. All right, guys, here we go. Second part. Find the vertex, the equation of the axis of symmetry, and the y-intercept of the graph of each function. Okay. Well, it sounds like vocabulary almost. What do I mean by sounds like vocabulary? You gotta know what the vertex is. You gotta know what the axis of symmetry is, and you gotta know what the y-intercept is. So y-intercept, nothing new, where it crosses the y-axis. Axis of symmetry kind of talks about that. You're gonna see it so much more now. And then of course vertex, well that's the highest point or the lowest point of your graph. So when we have a u, the lowest point, boom, down there, boom. And then of course it's upside down one. Highest point. But here we go. We don't have a graph to look at. We actually have the equation. So let's get a little help. Let's go to the internet and find something that's going to give me the answer. No, just kidding. So I can give me the answer. It's going to give me the information that I need to be successful. So right here, as we see this, right? Quadratic function, vertex form. Okay. To get the vertex of a quadratic graph, h is equal to -b over 2a. Okay. So hk is the vertex, according to that a little bit. But I need x is equal to -b over 2a. Now we say x, it has an h in there, don't worry about it. X, y, hk, you get it. But I basically am plugging in to find the vertex. Plug and go, guys. Just gotta know what to plug into. So we're plugging into -b divided by 2a. My b is -8. My a is 2. And of course, where did I get that from? You know, because you watched chapter 8 videos, ax squared plus bx plus c, ABC. Easy. You got it. And if not, go back, watch some other videos. Plugged in, a negative times a negative is a positive, of course. 2 times 2 is 4, so 8 divided by 4 is, your axis of symmetry is 2. And when I say it's 2, well, y is equal to 2 times x squared minus 8x plus 6. You plug in to find the y value, and that's what we're doing. So I'm plugging in the value of the vertex, 2. X is 2 for the vertex. So here we go. Well, I'm still showing it. HK, said that earlier, right? So HK, basically X and Y. We know X and Y is just, they're using different variables to, let's just be real, complicated, but there's reasons for that, you know. But we ain't gonna get into those reasons. So we plugged in the 2, which was our h, our x value, so that we can get the y value, or the k. See, don't complicate it, just find the vertex. Plugged in 2, 2 squared is 4, 2 times 4 is 8, 8 minus 16 plus 6, and boom, I'm a little behind, but you see it, y equals 2. So now I get the vertex of 2, 2. Yeah, I don't like it, so you're saying 2. There you go, 2, 2. That's the first part of my answer. Yeah, that's right, I had to do all that. It's not all that once you kind of get it, because all I did was divide 8 by 4. And I got the answer. All right, so a little bit more description and understanding of find the axis of symmetry. Okay, here's a different graphic organizer resource to help us out. So you see it here, guys, you have the ABC. We talked about that, right? There it is, no h and k in this one, just as I did it. X is equal to negative b over 2a. They show how they plugged in, they show how they got it, so that's exactly what we did, guys. Only thing is, they use values that we didn't use because we had a different quadratic. Their a was 1, our a was 2, so on and so on. But to get the y-intercept, because we've done 2 already, the vertex, the axis of symmetry, now of course for the y-intercept. And nothing's changing for the y-intercept. And when I say nothing's changing, think back to linear equations. When you have to get the y-intercept or the x-intercept, we plugged in. That's right. So when x is 0, what's y? That's all we're doing. Plug and go. So got my 0 in there. 0 squared, guess what is 0? Negative 8 times 0 is, guess what? 0. So you gotta love it. It's gonna be easy because 0 will cancel out all those coefficients. And boom, bang, pow. So I'm writing it as a coordinate because I'm good like that. There it is. So 0, 6 for my y-intercept. My axis of symmetry is 2. And of course my vertex was 2, 2. So let's do that again because we're basically just plugging in. And this is why notes are key. If you're in class and the teacher has some notes and you kind of wrote them down, you kind of got them, just go back and see where he is, or she, highlighting the formula that we're using. And what formulas are we using? Well, to find the vertex, we're going to use x equals negative b divided by 2a. And of course, for the axis of symmetry, well, guess what? We get it when we get the vertex. It's all the same. So, showing the new technique, now that I explained it, let's get it. So, x is equal to a negative parentheses. Well, write the formula first. It helps you to remember it. X is equal to negative b divided by 2a. So negative parentheses divided by 2 parentheses. And what's my a? What's my b? What's my c? What's my c? And there we go. 1, 4, 6. So b is 4. And a is 1. So we got negative 4 divided by 2. And guess what you get when you divide 4 by 2? 2. But since it's negative, x is equal to negative 2. You just got your vertex. I'm sorry. You just got your axis of symmetry. Let's go get the vertex. And to get the vertex, I'm using the quadratic and I'm plugging in. The quadratic says y equals, so here we go, let's go get the y. X squared plus 4x plus 6. Plugging in the value of x for the axis of symmetry, negative 2, and solving for, or simplifying for, I guess I could say solving, because we're saying y equals, so we're getting a solution for y. And there's your math, negative 2 squared, 4 times negative 2. Don't forget to add that 6. Already did, because 4 plus 6 is 10. So therefore, 10 plus negative 8 is 2. The coordinate I'm looking for is negative 2, positive 2. And for my y-intercept now, again, all I'm doing is plugging in 0, so I can find the value of y when x is 0. When x is 0, what's the value of y? That's how we're getting our y-intercept. Give me a hell yeah if you got a calculator next to you. My editor is going to get mad. He doesn't like when I say that word, but gotta be me. Bearded math, brother. All right, we did that. We got that. We're done. Number 5 is done. So literally, quick, take a picture, right? that's how I would do it in class, and I would say, hey, don't complicate it, right? So again, number 6, let's not complicate it. We gotta get 3 things: the vertex, axis of symmetry, and the y-intercept. Which one do you have mastered? Which one's still a little confusing to you? Or, you've already fast forward to get to the last part of this handout, right? Oh, here we go. Y is equal to negative 3x squared. Where's my square? Minus 12x plus 3. Where's my square? Oh, look at that, man. Now that's not a mistake. You ain't gotta put no oops all over my head, man. Goodness gracious. So, A is equal to negative 3, B is equal to negative 12, and C is equal to 3. So I'm plugging in for B and A. B is negative 12. Not enough room. Want to make it a little bigger, I guess, huh? There we go. Negative 12. Now my parentheses is a different color. And negative 3. Negative 3. Hold on. Yeah, that's right, negative 3. See, I told you my OCD kicks in. I couldn't let it be red. It had to be white. Yeah. Y'all know if you've been watching these videos. And negative 12 divided by negative 6. And you see I still have a negative of negative 12 divided by negative 6. So now negative of 2. Because 12 divided by 6 is 2, and negative divided by negative, so x is equal to negative 2. So now y is equal to negative 3. And again, there's my square. I'm not going to put it, y'all. I'm going to put it. It's going to come in here. So I love it. Because if you're struggling, do you see Mr. Kraft struggling right now? Is the bearded math brother struggling? Yes. You're going to struggle. If you ain't struggling, you ain't living. Right? So that's why we're here. Get that help. Well, there's the square. I told you. Believe in the process. Believe in the process. There you go. So, did I lose you? Negative 3 times 4, because negative 2 squared, minus 12 times negative 2 is negative 24. So I kept the minus and I did a positive times a negative, gave me negative 24. So I have that constant on the end of plus 3. So y is equal to negative 12 plus 24 now, negative times negative, minus 3. So just doing math, guys. Order of operation is never going to go anywhere. All right, you'll be doing calculus, trigonometry. You'll be in college, and your order of operations will still be a part of your life. You know what I'm saying? So, did we get an answer? We did. All right, guys. Y is equal to 15. So, got my coordinate. The vertex is x is equal to negative 2. Y is equal to 15. Now, if you have your vertex, you have your axis of symmetry. It's the x value of your vertex. It's literally like a little line that goes right down the middle of that U that makes it reflective. Beautiful thing. It is a beautiful thing. So x is equal to negative 2 and the y-intercept. Oh, we got some work to do. Did I already do it? I guess so. No, I didn't. Yes, I did. I don't even see it. I'll be honest. I don't know where I got that from. But yes. Oh, I know where I got it from. Pause. All right, I'm not pausing. It's already gone. This one's moving, guys. I remember you just plugged in 0, so negative 3x squared. So gave you 0, gave you 0. It was 6 on the end. You got it. Part 3, consider each equation. Determine whether the function has a maximum or a minimum value. State the maximum or the minimum value. And what are the domain and range of the function. So guys, this was that first objective where you can analyze and understand a quadratic function. So literally, we're going back to me sitting here with my hand in front of you talking about it's an upside down U. It can't go any higher. It has a maximum, right? Or the other way, as you can see, if your A is negative, it's going to be upside down U. So now since it's going upside down, like I said, it can only have a maximum. But if it's a regular positive U, it's got a minimum, right? So minimum, maximum, minimum, come on. I'm gonna write it in there, come on. Maybe not. Hey, there we go. Maximum. The highest point of the U and the lowest point of the U, right? And that will be easy to determine. Just gotta get the vertex, and we know how to do that. We did it 3 times. Second part, state the maximum or minimum. Well, that's when you get the vertex, you do that, and then we'll go through domain and range here. So first one, we have a very short quadratic. It's only one term. So it's gonna have a minimum because it's positive. That's it. I ain't gotta tell you a value for it. It just asks, determine whether the function has a maximum or minimum value. Okay, we can do that. And here it comes in yellow apparently, right? Bam. Second one, well here and here, so it's all gonna be in yellow, I guess, to give the value. See how I use color coordination to make sure you guys understand what we're doing? And if you don't understand, don't worry. You got the next day and the next day. Because a lot of times you're not going to get it the first time. And that's why I let kids know. Don't worry, the struggle is part of the process, right? So as we're looking down, what did I drag in? I dragged in what we used earlier. What we used earlier was these formulas to find the vertex. That formula was, and again it says h, I'm going to replace h with x. X equals negative b all divided by 2a, right? I get that value, I plug in, I get the k value, or in this sense the y value. So that's what I'm going to do. If I want to get the value, if it's 6, it won't go any higher than 6. It won't go any lower than -3. I got to give that value. So let's go get it. For number 7, a is 2, there is no b, there is no c, so therefore it is 0. So I'm plugging in 0 for b and 2 for a. And this is what we know. 0 divided by 4, you tell me. There we go. So now 2 times, and again, we're getting the coordinate because again, the y value. Because again, up or down, how high or how low will it go? So y is equal to 2 times 0 squared, well guess what? 0. So literally the origin. That u is gonna hit at the origin. Boom, it's not gonna go any higher, right? Next one, we're gonna do the same thing. Using the vertex. So let's get it. A, B, and C, one more time. And, or is that how you formula? That's how you get it to memory, write it every time. So x equals negative b divided by 2a. A is equal to 1, B is equal to -2, and C is equal to -5. We've done the same thing from the beginning of the handout. We've just used it to answer the question that they're specifically answering. So I plug in -2 divided by 2. I'm sorry, let me say that again. A negative of -2 divided by 2. 2 divided by 2 is 1. So if x is 1, then what's y? Well, y is equal to x, which is 1. So 1 squared minus 2 times 1 minus 5. You get 1 minus 2 minus 5. You're going to get y is equal to 1 minus 7. Y is equal to -6. Bam. Give me a -6. There we go. All right. And last one over here. I don't think I'm going to be able to fit that in. We're going to have to make some room. And we got a little bit of time to make sure you understand. If this is confusing you guys, this skill, to me, is different than the skill of graphing. When it comes to that standardized test, when it comes to you getting, wow, everything's moving. When it comes to you getting an A or a B, that's what I'm about. Your understanding and you being able to graph a quadratic, excellent. Can you describe the axis of symmetry? Huh? Well, let's go. Because now you're at the B level. You're at the B plus level. But to break down and discuss the minimum, the maximum, the axis of symmetry, is showing your clear understanding of the concept, which is why you have an A, right? So for number 9, clear understanding. What are my coefficients? A, -1, B, 4, C, which is not a coefficient, which I just wrote wrong. Mistake! All right, what's the mistake? C is equal to -1, but we're not even using the C. I'm not even gonna get the problem wrong because I plugged in B, which I wrote right, and I plugged in A, which I wrote right. So guess what? That's not gonna affect me in doing this problem. So again, If I'm doing 20 of these and I get one thing wrong, hey, I'm doing pretty good, right? So if you're doing this and that's where you mess up, that's all right. You're knocking this out. So, got it in, y equals 3. And yeah, we're good. What we're trying to do now, state the maximum and minimum value. Did that. What are the domain and range of the function? I guess I wrote the vertex because I felt like it. I don't know. But on part C again, does it ask for the vertex? I'm just being fancy. You fancy, huh? I know. I knew that. Service, no service. Fancy. I'll tell you about the logo later on. You got it coming for geometry videos. I'll let you know. All right. So C, guys. What are the domain and range of the function? So as we did earlier, remembering that domain is what x values are part of this graph, part of this function, and what y values do you have. So again, if the u, and it goes on forever, so it keeps going up, up, and up, it's going to be all those y values, right? So it keeps going on forever. Same thing for x. So for 7, again, it's going to have a minimum or it's going to have a maximum. So the range for number 7, since your vertex is 0, it's going to be everything greater than 0 because it's a positive leading coefficient. It's a regular u, right? Just like that, right up there where it says maximum in blue, minimum in red, it's going to be greater than. So for number 8, looking at the vertex, -6. So that's the magic number, -6. So think about it. I visualize a coordinate plane. I go to the left one, I go down. Nope, I go to the right one and down 6, and now I got a u right there. Well, guess what? All the values for y have to be greater than -6. Y is greater than -6. I literally just have you come up to the board, touch it, and go, okay, do you get it now? I get it. And whether the kid gets it or not, they visually and physically have walked up and understood that u is going to go on forever that way. So it'll be all the values greater than what's the vertex, right? And that's it, guys. Did I cover number 9? Doesn't look like it. But we're in a good 40 minutes. You got what you needed. Glad I was here to help. Can't wait to see you in the next video.